All right, can I do the meeting please, real quick? We're about to go live here, Dave. Yeah, yeah, yeah. Let me do the general meeting, and I'll be right with you.
Okay, we're
Appreciate it,
live,
Jesse.
Keith.
Whatever it may be. Okay, we're good. All right. A couple more coming in. All right. Regardless, welcome one and all to the July 13th, 2026 general meeting of the Los Angeles Astronomical Society. I am your Lord and Savior and President Keith Armstrong. Yeah, that's it. Sorry, I got here a little late instead of way late, so I'm feeling powerful in the moment. It's okay. Okay. All right, as is tradition, you guys can come in. Oh, all right, you can't come in. All right, let's see. As is tradition, I will ask if anyone around here are new members and would like to be identified as such. Introduce themselves. All right, we got one. All right. State your name and purpose, sir.
The name is Omid, OMID, and what was the other one?
I was just joking around. Why'd you join the club?
I'm turning back to an old hobby. When I was a teenager, I used to do a lot of astrophotography. My dad bought me a telescope and then a camera when I was 13 or 14. But then I got busy with study and grad school, and then now I'm coming back to an old hobby, basically. So I decided to join the club to get more involved in the activities that you guys are doing.
Awesome.
Thanks so much.
Well, welcome. This is a good place to get your beak re-wetted, as they would say. All right. Anyone else here like to introduce yourselves? We got one? Yep. Go.
Hey, I'm Matt, and I'm just joined, and I kind of joined because I had a telescope that I haven't really used very much, and was looking to just always had an interest in astronomy and stuff. I work at JPL, but I don't work on the astronomy side of it, so I thought it would be fun to get more involved with that.
Awesome. For the both of you, I would recommend stopping by Garvey Ranch Observatory on Wednesdays. That way you get to meet a lot of the regulars and figure out what it is that you want to, how best to participate and what makes the most sense for you. Hey, Shane. All right, what about in Zoom? I see all the faces. I recognize everybody on there too, but who else? Are there any new faces on Zoom that would like to announce their presence? The silence, deafening and comforting. Okay, that being the case, here's the agenda for the evening. We are going to go right to our speaker. Then the speaker will do some Q&A for us. Then I will run down the announcements. I will, at that point, announce the good heavens for the candidate that I felt was best deserving as such this month. Then we will do door prizes. Then I will announce the schedule of events for this month, and then we will be back in the cars, back in traffic again. All right, or you can stay here. We're just gonna stay here in the Lenny. That's good. All right, less traffic. All right, this is not engaging at all if you're on Zoom. Sorry, guess you had to be here. There's a lot more people here than there were the last time I looked up. Thank you for coming.
Keith, how many people are there approximately? Folks had asked in the audience.
We're getting an official toll here. 23. We got 23. You look more like 30 though. You guys are killing it. All right, let us move on. Let's bring Vice President Laura May Avron up here to announce the speaker for the night.
Hello, everyone. Thank you for making it up here despite it being a Greek night. So our speaker tonight is a very special person. All of our speakers are special. But I first met our speaker by actually watching a talk of theirs a couple years ago, they gave a talk on their work with SETI data, and I thought it was absolutely brilliant. And then I was lucky enough to get to work with the speaker at the EYU. So to give you a little bit about their background, Megan Grace Lee is a PhD candidate at UCLA dedicated to making the complexities of the universe accessible to everyone, human or otherwise. Cats included? Or who are we including? So she is in the Department of Earth, Planetary and Space Sciences, EPSS. She uses deep learning and convolutional neural networks to tackle challenges in signal processing, with a focus on radio frequency interference, RFI mitigation, for the search for extraterrestrial intelligence. SETI. Did anyone here have SETI like 20 years ago running on their computer, right? I did too. This was a good time. We thought we were actually going to find aliens. It's pretty exciting. We might, maybe tonight. So she earned her BS in physics, astrophysics from UCSD in 2022. And beyond research, she is a prominent voice in science media as a host for the EYU radio show and president of Exploring Your Universe, EYU, one of the nation's largest K-12 science outreach festivals. Her talent for turning complex data into compelling stories earned her recognition in the UCLA Grad Slam, where she was named the 2025 Audience Choice winner. She has 4 cats and practices yoga every day. But I do want to tell you guys, if you've never been to EYU, I highly recommend you go. It takes place in November 8th at UCLA. It is an amazing science festival. It's the biggest I've ever seen. I've always been blown away how you've managed to both be a wonderful, incredibly intelligent researcher and also coordinate this. So thank you for your mission in sharing all of this science with us, everyone at different levels especially. And thank you for being with us tonight. So if you'd like to come, take the floor.
Thank you, Laura May. That was really, really sweet. Okay. Do I share screen? Is it available?
Where is the... I'm not the liaison tonight, so I don't know which one is the... let's see.
Stage computer?
Yeah.
And then... Can our folks on Zoom see this?
You can see your background right
perfect.
now.
Can we get the liaison down here?
Yes.
So we need to share from here.
Okay, we can see it now.
Perfect. Well, good evening, everybody. My name is Megan Grace Lee. I use she, her pronouns, and I'm a PhD candidate at UCLA, where I work with UCLA SETI. So being a PhD candidate is going to sound a little foreign if you've never been to grad school. It means I'm 1 year and 1 grilling session away from being called a doctor. So what happens is, in about a year from now, I'm going to get in a room with my advisor, a few other professors, and technically the public. So I expect you all to be there. You're all invited. Everybody's going to dress up as different eras of my life. It's going to be a big party. But more importantly, the public is allowed to stop me from becoming a doctor. So if you show up and you have the best question in the world and it stumps me and my advisor is like, you know what, she doesn't deserve to be a doctor, I will simply not be a doctor. Anyway, let's use today as sort of like a practice run. So stop me at any time. Ask me the hardest question you can think of. We'll just try to stay relatively grounded, but relative is an operative term when our topic is aliens. Okay, let's get started. I'm opening with a little thought experiment. What do we think ET looks like? If you take out your phone and scan this QR code, and then if whoever's monitoring the Zoom can make sure that the QR code's working, you can send me whatever image you want in PNGs only. And if we're not pressed for time, we will have a demonstration with these images at the end of my talk. Can at least one person confirm that the QR code works? Yes, it works. Oh, there's no internet. Okay, Griffith Park Observatory free Wi-Fi.
I don't know what.
So this is LAAS, I'm going to say.
Yes, right.
Yay. Okay. I'll give everybody like 2 or 3 minutes to send in your best blue steel or whatever. When I do this with children, they often send in their teacher. I did this with college students. They sent in a terrible photo of their professor. And, it came up later and he's like, where did you guys even get that picture? So hopefully we see some good stuff. Okay, anybody still waiting?
Who is that?
Okay, so who exactly am I and what am I doing here? I'm an astronomer at UCLA. I'm a third generation Bruin. My family immigrated here from Taiwan when my grandpa was pursuing a PhD in system sciences, which is sort of the predecessor to engineering. My parents both went to UCLA. They got together on Bruin Walk. The rest is history. I now go here, and my brother recently got in here. So we are a UCLA family through and through. That is my story, but I actually didn't get in for undergrad. I was rejected. And so I went to UC San Diego, and now I just want to highlight the importance of good mentorship in your life. Dr. Karen Sandstrom took me in when I was a terrible, terrible little 17-year-old. I told her I wanted to work for Elon Musk, but I had zero programming skills, and will you please give me research so eventually I can go work for him? For whatever reason, she led me into her lab, and she taught me Python from the ground up. I always thought I was behind because I felt like the boys my age were allowed to learn Python in high school and I didn't start until college, but thanks to her, I caught up. I am so eternally grateful to her. And she also helped me get into my next internship, which was at the Berkeley SETI Institute. So there's me on the right and there's my advisor, Dr. Sophia Sheikh, on the left. I don't know if you guys can tell, but I'm actually very, very ill in this picture. This is sort of a huge part of my life. I'm very red and swollen. I'm about like twice the size I normally am. It's not weight loss, it's like swelling and eczema. Something about living in the Bay Area just made me extremely, extremely allergic to everything. I remember I was walking on the bus and I was so ill. I was trying to walk to the back of the bus because that's where the cool kids sit. But I literally couldn't make it because I was out of breath. And so I sat down in the disabled seat and I realized, oh my God, I'm disabled. So that made choosing a grad school kind of hard, but I got really, really lucky in that Jean-Luc Margot at UCLA took me in, and I love him so much. The health issues never fully went away. Sometimes I'm at the doctor's office or in the hospital, but Jean-Luc is always there for me, and he'll even fill in deadlines when I'm stuck in the ER or something. So always thank your teachers. If there's a good teacher in your life that kept you in the field you wanted to be in, this is your reminder to send them a thank you letter. Okay, so in today's talk, I'd like to answer 4 questions. Firstly, what is SETI and why should we do it? It sounds like a lot of us know what SETI is. More specifically, how is SETI done at UCLA? Are we alone in the universe? I think no, but we're going to find out. And finally, the question everybody is asking in 2026, how does AI play into this? Okay, could I get some audience participation for the S in SETI? Yes. 4. Extraterrestrials. Intelligence. So my PhD is in the search for extraterrestrial intelligence. And if you've never heard of this before, it sounds crazy. It has nothing to do with UFOs. Everything I do is scientifically backed and can be peer-reviewed and proven. That is what separates me from people who study UFOs. I have nothing against them. It's very difficult to recreate the conditions that create a UFO sighting. But the stuff that SETI searches for is stuff that can be reproduced so that your peers can also say, yes, I also saw that sign of extraterrestrials. So my job looks a lot like Jodie Foster's job in the movie Contact. Who's seen Contact? Okay, my fun fact about Contact is the upholstery in the telescope that she went to is still the same. So when I visited, our radio dish a few years ago, I was like, this looks just like the movie because it hasn't been renovated in however many years. Anyway, so she's a scientist, but I really want you all to understand that SETI is so incredibly interdisciplinary. You all, I don't care who you are, can have a place in SETI because we really need everybody's brains in this. So Jodie's a scientist. We got Amy Adams. I don't know what her name in the movie is, but she's a linguist in Arrival because the aliens come here and they're speaking this language that nobody else speaks, and somebody has to figure it out starting from nothing. So this is a huge piece of theory in our field right now. Like, if ET is contacting us, how are we going to understand what they're saying? So already we need scientists, we need cryptologists, we need big thinkers. In ET, he has to phone home. We need engineers. We need people who can build these telescopes, build the machinery needed to contact an alien and have them contact us back. And finally, there's always a lot of like diplomacy involved. So you got like the military, the politicians, people to fight. I don't think the aliens are going to come to fight us, but SETI needs everybody. We need people in space law. We need people in philosophy, because otherwise we become what we consider anthropocentric, which is when we just expand thinking everybody is like a human. So humans are otherwise meant humans are aliens, and this is why. So why is SETI important to me in particular? I'm going to assume that I'm preaching to the choir here when I say that big academic decisions, like how should we look for aliens and what kind of aliens should we look for, were typically decided by only a select elite few for many, many years. The doors are starting to open now, but the room is still quite closed. I know that as a woman of color, I could not have been allowed to be making these scientific decisions 30, 40 years ago, and I'm so grateful that these days I'm able to. But I'm not above realizing that I have a lot in common with everybody else who's in the SETI discussions with me. If you have like a cell phone that has access to Gmail, we all have so much in common. And we're looking for things that we don't quite know anything about. So if you were a cloud scientist looking for clouds, you'd start off by thinking like, I know that all clouds are white, puffy, and in the sky. So I'm going to start looking in the sky. If I see something white and puffy, maybe it's a cloud. But with aliens, we don't have a starting ground. We can only think about what life is like on Earth and try to extrapolate that into space. And so I think we should try to have the most diversity of thought for life on Earth when we start to extrapolate that into space. Ideally, we somehow remove the human factor from it completely, and people try to do that by thinking about things like, what would an octopus look like if it lived in space, or what would a dolphin look like if it lived in space? But this is extremely difficult. And so I want to invite you all today to think about what aliens might look like. Hopefully you submitted an interesting picture. But I'll get off my soapbox. I think everybody should participate in SETI. So we are a global effort of researchers. I think that there's like maybe 200 of us. And some of us search for what we would call biosignatures. These are signs of life on other planets. And who's heard of James Webb Space Telescope? That is a huge instrument right now looking for biosignatures. An example of what biosignatures might look like are some of the things we see here. So this is Earth shine. This is what Earth looks like when it reflects back off the moon. And so if we saw something like carbon dioxide and methane and oxygen on another planet, we might think, okay, there's probably life there. It's breathing in the oxygen, breathing out the carbon dioxide. But there's something really like interesting about all of these signatures that can be created by living things. They can also be created by rocks. So most of the things up here can also be explained by volcanic motion and plate tectonics. And so even if we saw a spectrum like this on another planet, we could not definitively say that that was life. This is a huge field right now, exoplanet atmospheres. If you follow their stuff, this is a very competitive field. It's extremely fast-paced. I think what they do is super cool, but I also don't think that within our lifetime, we will be able to definitively say whether or not the stuff they see is life or something else. That's highly controversial, so I'm shocked no one stopped me and said anything. So there's another way that we like to search for life on other planets, and that's called technosignatures. This is signs of technology on other planets. An example of this is the Dyson sphere. Who's heard of Dyson spheres? Yeah, so I know they came out as an April Fool's joke, but I take them very seriously. So over here on the right, we have in the dotted line, the heat that would come out of a regular star's brightness curve. If you're familiar with astronomy, that's going to look really normal. If not, all you have to know is that regular stars are dotted lines. But if a star had a Dyson sphere around it, that is like an alien civilization was trying to harness all the power of its star by building a lot of solar panel type structures, we would see that line created by X's. And so there's a lot of scientists right now looking at various stars and trying to see whose light curve looks more like that second one than the first one. Of course, though, didn't life create the Dyson sphere? So is this technosignature also a biosignature? I like to say that SETI is a group of researchers looking for technosignatures, biosignatures, and everything in between, because we're all kind of connected. Biosignatures include things like pollution, but that's also kind of a technosignature. I don't really think it's that important, but I know a lot of people know this word on the left, so I have to bring it up. If you see somebody who is trying to tell you about this word on the left, you can start preaching about technosignatures to them. For the rest of this work, in case you couldn't tell, I focus on technosignatures. That's what we're going to be learning about for the rest of the day. So I look for technosignatures along with UCLA SETI, and what's really special about us is that we never do this alone. So there's my advisor, Jean-Luc Margot, me, and then every year we invite a class of 25 to 35 undergraduate and graduate students to work on this search with us. We believe co-authorship is a free gift. If you're an academic, you know how important co-authorship is. Anybody who takes our class is automatically co-authored onto the publications that they work on with us. Here's some photos of some of the previous years. I think this is 2016 to 2019. I started school in 2022, and Jean-Luc forgot to take group photos, starting from when I got there, so I'm not in any of these pictures. But I am in that last final paper. Yeah, that one's got like 100 co-authors in it, because we were using data from several years, and so there were several classes worth of students. Our SETI course is one of a kind. This is not an ad for UCLA, it's an ad for why you should bring students into every part of astronomy with you. We bring the students to observe on the Green Bank telescope with us, so they come to the observation. They plan the observation, they get to pick targets. They get to name targets after them. My favorite signal of all time is named after a previous SETI student, and I think that's so special. We teach them how to code. I learned firsthand just how important it was to have someone teach me how to code, and so now I get to pay it forward and teach all these undergrads and other grads how to code. They learn about celestial coordinates. They learn about detrending signals. And yes, at the end of the course, they're all invited to contribute with us. A lot of them stay with us. We have an undergrad who's been with us for 3 years now who started off in the course. So if you know somebody who goes to UCLA, tell them to come take our course. On top of all this, it's a very easy A. I need to just reiterate, it's so important to get people in science. Like, we have like English majors and sociology majors and all this stuff, and they come up with the best ideas. Some of them came up with stuff that's going to end up in my dissertation. Astronomy really is for everybody. SETI especially is for everybody. Okay, this is the telescope that I use. This is the Green Bank telescope in West Virginia. She is about the diameter of the Hollywood sign. She's huge. You land in West Virginia and you have to drive like 3 hours. Well, my partner has to drive me 3 hours through some very mountainous rural road. You get here and then there is no internet, there's no service. You can't use your cell phone because your cell phone is going to interfere with the telescope. I'll get to that later. But basically, what you need to know about this telescope is that it can tell us if radio waves are coming from space. Bless you. I don't know if you can tell just how large it is from this picture of me. Also, I'm terrified standing there. It's 434 meters high or something like that. And then, yeah, this is the width of a football field or the Hollywood sign. So specifically, what I'm looking for and what all of these students have been looking for with me is this sort of drifting radio signal. If you want to turn your brain off after that, that's okay. If you're super nerdy, what we're looking at is a frequency time diagram where we have some narrowband signal that is coming to us from space. So a narrowband signal in our case is going to be something of 10 hertz or narrower. And this is not something that's created by things that are existing in space. So maybe we know about other radio loud objects like pulsars, fast radio bursts, radio loud galaxies. Those are all going to be much wider in frequency space. And they don't really do this. They have things like a kilohertz bandwidth signal, and we're looking for something that's like 3 hertz wide. It's also really important that our signal is drifting, so we want something with like a diagonal line. That just means that there's some kind of relative acceleration between us and the signal. If we had 0 relative acceleration, it's probably Earth talking to itself. Who's seen this before? Okay. It wasn't 0 people, that's pretty cool. But basically, if we see that thing, we're going to know we found aliens because there's nothing in space that just makes that randomly. So yeah, UCLA started looking for these narrowband radio technosignatures back in 2016. So we've been doing this for 10 years now, and we've searched quite a few stars. This isn't quite updated with 2026 numbers, so I think we're closer to like 80,000 stars that have been searched. And from that, we have gotten 106 million candidate technosignatures. So 106 million times we have seen something like this come into the telescope. So what constitutes a candidate signal is that something is very, very bright and powerful in a background of things that aren't as powerful. If you've taken stats before, maybe you've heard of the prominence, but basically, out of these things, we would want something that is very dramatically larger than its neighbor. So like the center one would count, but these peaks on the left wouldn't count. It's okay if you miss this whole slide. It's just in there for legal reasons. You guys wouldn't believe some of the questions I get. So who thinks that 10 of these signals were ET? Okay, we have a believer over here. One of these signals is ET? Okay, no, yeah, some ones. Basically, we haven't found ET yet. And this can sound really, really depressing because you're like, how have we searched 80,000 stars, gotten 106 million candidate technosignatures, and still not found ET? I don't want you to feel disappointed in the search for extraterrestrials. I want you to feel disappointed in humanity. We're terrible at searching for aliens, you guys. This is my entire life, and I'm telling you right now, humans are not very good at this. I personally am trying my best, but I am one person who doesn't even have a PhD yet, so it is rough out there. For a second, I want you to imagine that everything in space, all the stars, all the planets, all the wavelengths, all the timescales, all the drift rates, whatever, was the size of Earth's oceans. Humanity has searched one jacuzzi tub's worth of water of what could possibly be out there. Nobody is having a telescope on the sky at all times looking for narrowband radio signals or any sort of SETI signals for that matter. The reason why this hasn't really come to fruition yet is because they don't want to do it. People don't really think this is a worthwhile opportunity. The reasons I think it is are because our galaxy has hundreds of billions of planets. The type of signal I'm looking for is unambiguous. We're not going to find it and have to throw it out because of some, I don't know, I think something else created a narrowband radio technosignature. No, an alien would have had to create that. Also, it's not really that expensive to look for these radio things. I think like an hour on James Webb will cost you in the millions. An hour on Green Bank costs you like $5,000. So it's really, there's no reason why we can't do a better job of this other than people simply don't want to. They think this science is fake. They think it's not worthwhile. They don't want to make new friends. I agree. Friendship is magic. Is that My Little Pony? My little alien. So I hope I've at least inspired you all today to be interested in the search for extraterrestrials. This is a real science. We're doing real, regular things. We're just looking for anything anomalous in radio. For us, that's something narrowband, but there's other things people look for. They look for like one bright pixel or like a long pulse line across things. There's optical lasers. There's the people looking for pollution. There's a lot of ways we could do this that we currently are not because of lack of like manpower and funding. So let's think back to our very, very large number of candidate signals. You all instinctively knew that they were an ET. I'm guessing that's just because you haven't read it in the news. But does anybody know where these signals are coming from if they weren't from extraterrestrials? Okay. I've heard a few right answers. So I heard black holes. That's not quite it. So black holes are well studied enough that somebody's going to subtract out the black holes. I heard hydrogen lines. The hydrogen line is the closest analog to the thing that we're looking for, but people know about that thing too, so they're going to take that out. And then there was two other answers I heard that are much more correct, and we'll get into that. So here's my little diagram. Imagine I am using the Green Bank telescope to look at something in space. but there's something in between me and space. This is a satellite, maybe to represent something like GPS or Starlink, and these things are also creating narrowband radio signals. This is a huge, huge problem. Now, if there's only one of these guys, we would just be like, okay, I'm going to subtract out every time I see it, but it looks a little more like this. And then, these days, Starlink, the competitors to Starlink, everybody and their uncle is sending some kind of radio frequency emitter up into space. And when they fly over the telescope, they look a lot like aliens. Ooh. So we call this radio frequency interference. Can you guys tell how much I hate RFI? There's like so many slides of me just adding satellites to this image. And so my job specifically at UCLA is to build a machine learning algorithm to remove the instances of RFI from our telescope data, because they are a big waste of time to look at. Before I got here, some grad student, which would have been me, just has to manually look at all 106 million of those candidate signals and rule them all out as RFI every single time. So my job is to accelerate this mission by using AI. Skip this slide if you're not interested. But the reason this is happening is because beam forming isn't perfect. So when you point your telescope up at some signal, you would actually be getting the source in this main beam, but all antenna, any ham radio enthusiasts have side lobes. And so the telescope has side lobes as well, and sometimes these RFI emitters come in through the side lobes. So what I did was I invited the entire public to help me understand these signals. We said, hey, what if we could at least categorize the different kinds of satellite signals that we're looking at? Then we could train a computer to recognize these kinds of signals and eventually remove them from our telescope data. This is my baby, my citizen science project, participatory science project, Are We Alone in the Universe? It is currently hosted on Zooniverse at arewealone.earth, but I'm currently out of data because our volunteers are so prolific. They go through like 100,000 signals in like 3 days. I just can't really keep up with them. They're very good. So we asked them some questions of some basic morphology things about the signal, and then they categorized them into some final list of 19 different categories. The idea is that eventually the machine learning model will learn how to be like the citizen scientist, also categorize radio signals, and then I can just say, okay, computer, every time you see this kind of radio signal, just remove it. Has anybody played this before? Really? You have?
Yeah, it's familiar. I think we may have done this like in I may have done this in undergrad, well, like years ago.
Very, very cool.
I don't know, when did you start it?
2023, Valentine's Day.
Then probably not, but something similar. I do remember. I remember that.
Something similar is good enough. But yeah, for my SETI at Home enthusiasts, this is the only other existing citizen science project in SETI. I know the public is really interested in looking for aliens, and so I thought it was really cool that my advisor and I got to launch this little video game. So these were the available classes that were on the platform. My favorite is probably the VIW, because it's like the most hated one. I'm really annoyed by that thing. You also saw that there's a talk board on our game. We have had many, many volunteers, and some of them suggest improvements to these classes. The original classes were suggested by like psychology students who took the SETI class, who were really interested in how humans might want to best answer these questions. So I didn't actually come up with these. I'm so grateful to the undergrads that did. But what we learned was that most of the signals come from the same 3 emitters. Of course, these are all RFI. I love RFI. It keeps me employed. So we found out that 68% of the signals that we get from our telescope are these main 3 categories of signals. I have so lovingly named them the flatworm, the 235 line, and the loom. Bless you. This other 33% is everything else. So if we were to see ET, we would expect it to be in this everything else category. So next, I train an AI to recognize those 3 most common patterns of RFI. And if you didn't understand anything in my talk, please understand this slide only. The AI in my project has nothing to do with LLMs. It has nothing to do with Gemini or ChatGPT or Claude or whoever. Did I ask them for help sometimes? Yes, of course. I needed that help. But that's not the same kind of AI I'm building. In fact, if you took the amount of energy it takes to power 1 LED bulb in a strand of Christmas lights, that's the amount of power it took to power my project versus powering an entire city is how much it takes to power an LLM. There are a lot of ways that modern day machine learning AI techniques can help astronomers. They're not job stealing. This is a job nobody wants to do. Trust me, nobody wants to look at these signals all day long for the rest of their life. It's not very fun. Any machine learning nerds today? Thanks, guys. So this is the shape of the convolutional neural network I have built to classify my signals. The final output, this is what it's important to understand, is it gives you probability numbers of whether something is a flatworm, a 235 line, a loom, or again, our other category, the possible ET. So basically, I give the model some picture and it tells me how likely is it that it is going to be one of those 4 things. My model is really, really good. I've gotten it to recognize everything with a 99% accuracy rate, which I'm very, very happy with. And then, of course, we want to know how much work are we saving future grad students? How much RFI can we automatically remove from telescope data? And we see that predictions with high confidence, meaning 95% probability or higher, are most of our data set, 90% of our data set. If you multiply that by our 68%, because that's how many are in those big 3 categories, you end up with quite a few images are going to be automatically classified. The model is also really, really fast. It classifies 100 times faster than a human can. So I will get to deploy this on my first set of observations ever, hopefully next week if I do my homework. The observations are sitting on my computer. I just need to run this on them. But yeah, so we're going to have the first ever human-labeled real RFI machine learning pipeline run on real data very, very soon. Thank you. I get a lot of complaints that we're going to accidentally throw out the ET signal if we're throwing everything out. So I'm going to run a signal injection pipeline on top of all this. I'm going to generate what ET might look like. Maybe I'll use your images and layer them on top of telescope data and make sure that my pipeline doesn't throw those out. So now we get to the fun part of my talk. How does my pipeline interpret a real technosignature? I got inspired to do this the other day when my printer left this artifact on a piece of paper I was trying to print out. I was like, this kind of looks like the VSN from my citizen science project. I'm going to ask my AI what it thinks this is. And it thought that this was ET with 51% confidence. So that's pretty good. Anything that's under 95% confidence on any category is going to get lumped into that ET category because somebody has to look at it again. We're not going to trust the AI that much. I thought, okay, I have to give it a picture that's at least SETI related. So that's me at the Green Bank telescope. I measure with the L band, so L band. It also thinks I'm an alien, and it's a little more confident with that. It gave us 55%. All cats are aliens. That's my daughter, Union. It thinks she's an alien with 53% of confidence. And if one cat worked, how about multiple cats? I have 4 cats, so I asked it about all 4 cats. They're all aliens. There's Meatballs in the top left, Stanley in the top right, Union again, and Stella. And then I got real serious. I'm going to make my images the same size and shape that I trained my model on. And so it thinks that this completely blank one is potentially ET. But what was interesting was that this other one that I just drew some random line on, it classified as a flatworm. This is objectively not a flatworm. But since the flatworm is the most ubiquitous type of sample, it might just try to take the easy way out and say, most RFI are flatworms. I'm going to say this is a flatworm. But since this one was not that confident, it would have still required manual inspection. Okay, any questions so far? Yeah.
I've heard about SETI for a very long time, and I've heard about the use of radio telescopes
Yes.
as a means of trying to find SETI. How is it that radio telescopes seem to be the primary instrument for this search as opposed to other technologies?
Yes, that is a great question. That is usually one of my slides. I removed it because I thought people didn't care about this. But there are a lot of reasons. So first of all, humans use radio to communicate with each other. It's not so outlandish to think that other civilizations might also be using radio to communicate with each other, because radio waves are not absorbed by things that are in space. So optical waves, if you have a moon in front of it, it's going to get blocked. Other things are absorbed and scattered by gas and dust and clouds, but radio waves are not affected by these astronomical sources. So I could see a radio wave coming from the other end of the galaxy. No other telescopes can do that. It's just us. So then it also goes conversely. Okay, if ET is trying to contact us, maybe they're going to use radio waves because they know that we can see them. Other than that reason, there's also the cost-benefit analysis, and then also the lack of ambiguity if we saw a narrowband radio signal. There are not a lot of other proposed technosignatures in other wavelengths that have this lack of ambiguity. Does this answer your question? Yes. Cool. Yeah.
Why specifically the L band?
Oh, why specifically the L band? I mess this up every time. There's this thing called the water hole, which has to do with the H2O molecule. It's got these two emission lines, and so they just call it the water hole. There's the hydroxyl line and the hydrogen line, and they're both in the L band. And so there's this idea of the Schelling point. We're all going to try to talk about something or near something that's very important. If I see a supernova and you see a supernova, maybe now we'll try to contact each other. And they're like, water is very, very important to life. Maybe we're all going to try to talk about water and talk near the frequencies related to water. There's also somewhat of personal spins on this. The conferences go on about this forever. People could talk about this forever and ever because there's really no way for us to predict what ET is going to send. There's only ways you can win funding for looking for ET, and one of those is the L band.
It's wildly inconvenient, but that's where GPS.
Yes. Okay.
Is there a minimum of OH absorption, or is it minimum of water absorption at that frequency?
That one I'm not sure. I'm sorry. I don't have it memorized off the top of my head right now. Somebody else has thought about that. Any question here?
Using laser light for transmitting signals now.
Yes.
So is anyone out there looking for these?
Yes, somebody is looking for these. This is Professor Shelley Wright at UC San Diego, who operates PanoSETI. I think PanoSETI will come online in the next year. Shelley and her grad student, Alyssa Johnson, are working on the first ever, I think, all-sky, all-time SETI search, and it will be an optical looking for lasers. Yeah.
What's the farthest distance in light years are you able to get that? Are you planning on getting to find this?
Okay. Our galaxy is 270,000 light years across, and we are sensitive to the entire galaxy. So quite far.
Are you talking about just our galaxy, or are you talking about other galaxies?
So I think GBT specifically is only really good at looking for things within our galaxy. I'm not focused on extragalactic SETI, but I know that there are other people who work on extragalactic SETI. I just think that it's going to require a little more technology, and there's a little less motivation for doing so, just because the nature of us communicating back and forth with somebody within our galaxy is already going to be crazy, because that's going to take you literally millions of years to send a text back and forth. So extragalactically, there aren't a lot of people who are super duper interested in doing that, because they know for sure we're never going to hear anything back from them. Okay. So I think we have time for our live demo. Did everybody submit a PNG file?
Yes.
Okay. This is really exciting, you guys. We're going to find out whether or not my AI thinks your photos are aliens. And if it does a bad job, it's a learning experience for everybody.
Even AI has to learn.
Yes. Okay. Okay, I see some microbes. I don't know who this person is, but we're gonna find out. That one looks interesting. Onion rings? That's an octopus. This is a self-portrait. Okay. Okay. I need to find my demo window. I'm sorry this is going so slowly. This is a good opportunity for everybody to continue sending in pictures if you haven't yet and want to. Oh, it's another one.
Tried to send a picture of Keith, but I can't find him.
And maybe if I open my... There we go. Aren't you their leader?
I was.
Okay, so you can see that I ran a sample image earlier. So I ran this on a 1040 tax form, and it did think that the 1040 tax form was aliens with a 99% confidence rate. Okay, I am kind of curious what people submitted. This is a photo of me at the Centennial this year. I'm going to guess Laura May submitted that.
We can only submit one entry.
Oh, really? Okay. That's really... Are these Muppets? Okay. There's our octopus. Our microbes. Who is this?
Okay, so the story is there's this like psychic that would draw your soulmate.
Okay.
So one of our friends got a response back, and that's what her soulmate.
Oh.
$22.95. Okay. Where's the white man?
Okay, honestly, a drawing of this caliber for $22.95 is really not bad. Like, my best friend is a professional artist, and like she would charge way more for this. Like, this has detail. The fact that he has facial hair and eyebrows, it's really good. Okay. And then what is this monstrosity? Telescope fish. Okay, so that's my kind of fish. Okay. Let's find out how we did. Okay. So this last one is me. It thinks I'm an alien with 99% accuracy. It did think that everything we submitted was aliens. So I think we've done a really great job of thinking what ET might look like. Thank you all for participating in this and not submitting anything too extremely disturbing. Yeah. Okay, I think this is the wrong presentation. There's a question?
Yes.
Yeah.
I was curious for your thoughts on the dark forest hypothesis.
Okay. The dark forest hypothesis is that we're teaming with aliens or that there's no aliens and we're alone.
Oh, it's that the universe is silent because anyone who makes noise is going to be killed. So it's like a dark forest where you can imagine people hunting anyone who makes noise.
I mean, my thoughts on a lot of these things, like, are we full of aliens? Are we not full of aliens? Is like, as far as my life goes, this doesn't really like matter that much. They're either going to kill us or they're not going to kill us. What matters to me more is who is going to get killed first. So what you need to know is that if they do show up and they are really, really mean, I'm probably going to go first because I personally poked the bear. The Medi people, the messaging extraterrestrials, they definitely poked the bear. I don't really think that that's what's happening because I think it's like a waste of resources for everybody to do this. Like, humans have not gotten to light speed travel yet. I think humans are really bad at everything. But I do think that if we got there, we'd be a lot more selfish with our stuff. Instead of just trying to annihilate, it would be much more of like a colonize, enslave, other words kind of thing.
We're fast on our way to becoming one of those dark forest predators. Better than alternative or worse?
Yeah, other question?
What's your explanation for
Okay, I'm gonna need a refresher on this too. The Fermi paradox. What is it?
It's the fact that there are no aliens. They should have already filled up the galaxy, and I don't think it's a paradox. I think the whole idea is
Yeah. Okay. The reason I don't know any of these things is because when they get taught to me, they're very quickly explained away by my advisor. And so I don't really like store these as well as I store like, this is the newest form of AI we can use for image classification. Like, that's what my dissertation's on. So I always feel really bad when I don't remember these pop culture things. It's not because I don't care about them. It's because at some point I did think about them, and then I got stuck in some huge, deep rabbit hole of trying to write my dissertation that this other, like, more fun stuff I couldn't really remember anymore. So the answer to the Fermi paradox is, of course, this idea that we have barely searched anything. It goes back to our jacuzzi tub in the whole Earth's oceans idea. We're just really, really bad at looking. So unless they're directly trying to communicate with us, and for whatever reason we're so bad at hearing that communication, which might be true because we would need a telescope to understand these communications, I think we're just doing a really bad job of looking for them. I do think that there are aliens out there. I think we will find them in my lifetime. I don't think Earth is that special.
I'm curious what you mentioned earlier that, the atmospheric searches you don't think will pull up anything of our living. And, if it doesn't get you into too much hot water with the atmospheric people, would you share your thoughts or detail why?
Yeah. So, I mean, I love the
Do you mind
atmospheric
repeating
people.
the question for Zoom,
But
please?
there are very few emission lines out there that are only specifically made by living creatures. Sarah Sager, who is in the exoplanets community, has very recently put out new work on it's something more similar to a CFC that for sure would have to be a form of technosignatures coming out of that otherwise exoplanet atmospheric science group. But things like oxygen, methane, carbon dioxide, what we normally associate with human life, can all be created abiotically through some kind of rocks, volcanic activity, and tectonic plates.
There is what's called the red edge feature of chlorophyll in infrared reflectance spectra. I don't know if are you looking at emission or?
Yeah. That's a good point, and it's another point to the radio question earlier. Things like infrared and optical telescopes, like the James Webb Space Telescope, they can look at something like 200 exoplanets. They don't have the quality to look for planets that are in the entire galaxy like radio does. So we could be looking for the red edge on other places, but there's so few places we can actually check. And if you guys look up right now, atmospheric spectra coming from other planets, it's quite fuzzy, it's difficult to interpret. Thousands of scientists right now are trying to interpret these things, and it's hard. They're quite degenerate. It's very, very complicated to figure out what elements are creating these spectra. Yeah?
Do radio waves travel more slowly than light waves?
No. They are also traveling at the speed of light. So if somebody was 2 light years away and they sent me a text, it would take me another 2 years to text them back. Yeah? Yes, that is correct. So SETI's God-saving grace to this is the Lunar Far Side Telescope. Let's put a green bank telescope on the other side of the moon. The person I know who works on this a lot is Dave DeVoer with Breakthrough Listen. I think he's very nice. He's pushing really, really hard for this Lunar Far Side Telescope. You can search LFT, it'll come up. They basically just need a donor. So they've already done all the science and engineering. They are looking, if one of you is a billionaire, for some, hundreds of millions of dollars to put that telescope out there. And then, yes, that would solve all the RFI problems. I'll be unemployed, but we'll have found aliens. Yeah, do you have a question? Thank you. Okay, so I'd be remiss if I didn't mention Exploring Your Universe at UCLA. This is LA's largest science fair. I am currently the president. This year is my last and final one as president. And this is a quote from me: "Science is for everybody." We are on November 8th this year. Laura May will probably be speaking again. I hope to see you all there. And thank you all so much for listening. If you'd like to follow along with my journey, there is currently a spotlight on me at college.ucla.edu, and then my personal website, megangrace.lee. And if you want to email me more crazy alien questions, you're more than welcome to. Thank you so much. way I personally see it. I mean, I always tell people when they're afraid of this dark forest thing, it has come up before, but it normally gets told to me in other words. Like, you guys don't have to worry about it. It's me that they're going to come after. It's going to be fine. I don't think that if aliens have figured out the means of technology for light speed travel, that they're going to waste their time on people like us.
Like Calvin said, the best proof there are aliens is the fact they don't come here.
Right. Would you choose us, Tim? You do. You choose us every Wednesday. He does. He always comes back. That's right. That's right. Glutton for punishment. Okay. Thank you very much, Megan. That was awesome. Everyone get all their questions out? We're good? Your thirst for knowledge seems quenched.
We have questions on Zoom.
Oh, we're going to Zoom it. All right. What do we got? Roman?
Jeremiah, you want to go with your questions?
Yes, you can read them, or should I read them? I don't want to.
Go ahead and read them.
Where should I start?
These are your questions.
Yeah, true. Okay, let me go. I'm just scrolling up. One of the questions is, what if the way the aliens communicate is through natural means, like a volcano, or like through natural, like through water, or like Earth, Captain Planet type stuff?
Yeah, I think about this a lot. So there's a huge reason why SETI is rebranding out of SETI into Search for Technosignatures. It's because the people who decided what intelligence was all these years ago when they wrote the definition were like, oh, people who make radio towers, people who make atomic bombs, these are all intelligent people. But I don't necessarily think like that. I think if humans were more intelligent, our Earth would look really different to space. Like, we'd have a lot more conservation going on, a lot less RFI, a lot less pollution. And so I do think that there is a chance that ET, in their infinite wisdom and how they are so much better than we are, is communicating through some other natural means. Of course, that's not really within our bandwidth to search for. Bandwidth's a really bad choice there. We're not really able to look for things like that right now because human science just isn't quite there yet. But there are people who think about this quite often. They come to my conferences. You would love hearing them talk.
Thank you. That was amazing. Are we anthropomorphizing aliens? Like you were saying, so say an alien race is harmonizing. They're all on one, like a hive mind, like, and maybe like how we own, and like bringing that out in like a tonal sound type thing. But because we have so many like satellites and just technology that when you leave like the city and there's like a hum and you go to nature and there's like not that hum of electronics, are we trying to give like human qualities to, and we're looking at them using our human tools instead of, like you said, maybe a different method?
Yes, 100%. As a person, I'm against this idea, but SETI right now doesn't have enough voices from people who are more non-astronomy, non-engineering type thinkers, bringing in these other ideas of how could we search for other kinds of, biosignature, technosignature, the stuff in between. I'm not like a firm believer that ET is going to have some very powerful radio beacon that's actually sending those signals that I'm looking for. I'm just a firm believer that if I saw those signals, that's for sure aliens. But I'm personally interested in the idea that aliens might look nothing like how humans do. I think that is what's going to happen. That's just, it's not my field. And I'm really, really interested to see what's going to come out of those conversations that are actively happening right now. A lot of this has changed after the 2020 pandemic. People thought one way about humanity and how humanity views science, and now we're kind of drifting a different way and thinking what I would say is a more worldly view of SETI.
That's a great explanation. Thank you. I just one more question. I have two of them, but I'll put them in one. What if the signals that we're receiving only hit near oceans and need to be near water, or the signals came millions of years ago or still on its way? And the second part is, what about the Hubble constant? The expansion universe is stretching the time for the signals to reach us. Is that because aren't we spanning faster than the speed of light, and maybe the signals are coming at the speed of light, almost like how the stars we see has a redshift and they're going away from us? Maybe the signal's going away from us and not toward us.
Yeah, that is definitely a high possibility. SETI is 100% high risk, high reward. There's a huge chance that one of any of those things, or possibly all of those, are happening to our signals. I'm not saying like, oh, they're for sure talking to us and they're going to be signals that we can hear and they're going to be, very easy to find. But I do think people are actively thinking of new ideas around those things. It's just my specialty is not trying to fix those more, I would say, like astrophysical problems. I'm much more on the final machine learning step right now. But there are people who work on what you're talking about.
Daniel, you want to ask a question?
Yes, exactly. Okay, thank you guys. Thank you, Zoom.
There's one other question we probably want to get in. It's probably a good one.
Okay.
And that is,
if it's
what
a
is
good
the
one.
Are you talking about mine?
Yeah.
Oh, okay. Sorry, let me read that out. Sorry. Give me 1 second. I'll read it directly from how I sent it. What's the protocol, as far as you know, to report a 99% confirmed ET signal? And how do you think the powers that be would go about disclosing it to the public?
Okay, we got a two body problem there. First of all, there is a post detection protocol. There is a post detection hub at St. Andrews in the UK. They work on this. They write this huge document that shows up at the International Astronomical Union every few years whenever they meet. It is a long growing document. Also had a huge overhaul after 2019. At first, it was like, scientists are going to tell the public we found aliens, and they'll all be like, yay, we found aliens. And then it was like, scientists told the public about COVID-19 and all hell broke loose. So now we know, okay, if scientists just tell the public we found aliens, we're more likely going to have war than anything else. And so they are rethinking how we want to do that whole segment of it. As far as what the scientists will do if we find this is we try to recreate it from as many telescopes as possible. So there is a possibility that, let's say I see it on the GBT, my colleague doesn't see it on the VLA, but that's because the aliens turned off their signal in between when I saw it and when they saw it. But the scientific community has agreed that we have to see the signal on multiple telescopes before we confirm that we have found a technosignature. And then I'm not going to make any comments on how the administration will disseminate it to the public. There was a signal that came out of Breakthrough Listen a few years ago. It's called BLC1. I think it got leaked via Vox article. Just awful. It was a cell phone tower.
Well,
yes.
Well, thank you. It's pretty rare that we have somebody like that's essentially on the inside, and that's a question that I always want to ask. Like, what do you think? How do you think it would go?
I mean, we just met today, but like the running joke is that like my close personal friends are going to be the first people to find out about this, just because like I can't keep my mouth shut. Like I've run home from work a number of times so excited that I found ET, just for everybody to be like, you're delusional. Even us with no PhDs, no special training can tell that was RFI. My partner will confirm this happens more than once. The cats are somewhat supportive. They sit on your keyboard. They erase all the things that you've coded that day. Why? How do I teach cats yoga? Yes. Well, I don't know. When you do yoga, your cat will come do it with you. I think my mom's on the Zoom call. My mom teaches a Saturday morning yoga class. You all are all welcome. Saturday mornings at 10:15 to 11. And the cat will just walk under her every time she's doing downward dog because it really thinks that we're all doing this together. Cats are kind of always in downward dog. They're great. Yeah, downward cat. They're great students.
Do you still want to go into industry, or are you considering staying in academia?
So academia might not be exactly for me. As far as publish or perish, I know I'm gonna perish. I'm not interested in working for Elon anymore. I dropped that like a week after I started talking to Professor Sandstrom at UCSD. I realized I was very short-sighted and didn't know what was going on in the world, as are a lot of college freshmen. So I don't know if there's a space for me in academia. As I mentioned, with the disability, it's really hard for me to move around, and a lot of academics have to move to the school that's willing to hire them. So if like the perfect academic position happened to open up in Southern California, I would definitely take it. But right now, I'm very interested in moving more into science communication and outreach and education and those kinds of things. I really fell in love with planning my science fair, and if there were more opportunities like that, I would love to continue educating the public on what actually happens behind closed doors of people who look for aliens. Yeah.
This is like a movie question. In Contact, they got a radio source from like a star that was close to us. Mm-hmm. And a lot of people think, oh yeah, aliens are listening to us and have heard our early transmissions. Have we at least looked at all of those close, like within 100 light years of us, to see if any of those are noisy?
So I actually did an experiment with this a while ago. Do you know about the Arecibo message?
Yeah.
I tried to calculate how many stars had seen the Arecibo message because the 50th anniversary of that just passed 2 years ago. And I was going to do like, let's do a fun little survey of everybody who's seen this for the past 50 years. It was 0 stars. Like, it would have to be our spillover radiation. So if the aliens happen to see like, just everybody's using their TV and this radiation is leaking out, they could see that. But I don't think any of our targeted messages have actually like reached anything yet. The size scale and therefore time scale of even nearby stars is so much larger than what I personally comprehend. I was really sad to find out that no one heard the Arecibo message. As far as has anybody at least looked at everything within like 100 light years, I'm going to go with no.
I don't think the spillover would go more than a few light years anyway before it became too weak to detect. Right?
Yeah.
Have you seen Pluribus? Is there any cool science in it? And what is your favorite sci-fi, written or TV or film, about finding alien intelligence?
Okay. So my job as aliens, I don't really like consuming alien media anymore. I don't know if this has become obvious with how I don't recognize these pop culture things. It's because like I work from 9 to 5 or, like 10 to 2, and then I'm done working. Like I'm not continuing to do this anymore. Like watching Contact for me is work. I saw it at a work retreat and that's why I've seen it. So I haven't seen Pluribus. And I know like Disclosure Day just came out and it has like really mixed reviews. I'm probably not going to see it. I did really like Arrival. I saw that before I started SETI, and I think that's why I'm very much like an Arrival stan. Also because I just appreciated how much interculture weaving there was, how like the main character really tries to put herself in the shoes of the aliens and then later on in the shoes of the other world leaders, and she really saves the day by being a good person who listens to everybody with empathy. That's what I really liked about it.
Should we conclude it on that?
I think Daniel had one more.
Oh, cool. One more question in Zoom land?
He's muted though. Here he comes.
Oh, sorry. No, I was just wondering, don't we have like a 200-year radio bubble? Like, and you don't think our spillover's gotten to anybody else?
No, I don't really think so. So the Arecibo message made it 50 light years away, and it for sure hadn't seen anybody. And then like somebody in the front row, what's your name? Tim, nice to meet you, Tim. Like Tim just mentioned, spillover radiation isn't going to be like super, super powerful by the time it gets there. I don't think Earth can detect Earth at 200 light years. I think we can detect ourselves at 50 light years. So there's either the ET have much better telescopes than we do, and then they would have seen us. There are definitely stars within that bubble. So there is a chance. But let's say that the ET had telescopes powerful enough to detect our spillover radiation. I think we would go back into, I don't think they'd care to bother us. And maybe that's why we haven't seen them.
See itself across the galaxy 100,000 light years away.
Yes, that is 100% true. And that's still true for Green Bank today.
I didn't hear what he's...
Oh, he said that the Arecibo beam and telescope could see itself. So Arecibo was a planetary radar. It sent out a beam and it could pull in a beam. Arecibo was able to see itself across the galaxy. That's still true for Green Bank. Green Bank doesn't transmit anything, but we could see something as powerful from across the galaxy. What makes this different from the spillover radiation is just the power that is sent in the beam. So mostly what my science is looking for purposeful communication where people put a significant amount of power into their signal as opposed to like just the haphazard spillover of our cell phones. Thank you.
There's no accounting for taste, Tim. You don't know them at all. Maybe it's elegant to them. All right, awesome. Let's get into some announcements. Firstly, I'd like to point out that we have a lot to do this week. So there is this, then on Wednesday we have Garvey. Thursday is going to be our big Silver Lake. Friday is going to be Mount Wilson. And then Saturday there is the Griffith Star Party here. And then also we have Family Night at SCAS on the same one. So rest up, make your plans. I'll see you at a lot of stuff. The lawn will be open. Yes, I think Tuesday night is one of Jeff's dinner parties, I believe. Yeah. Look for an announcement. Usually do them on Mondays, though. Yeah, you'll get an invite. Thanks. Oh, dude, you have no idea. That's it. That's how I'm going out as president. Between that and insults from Greg. Okay, the other thing that's worth noting is that Lockwood, SCAS, is going to begin its latest round of upgrades starting on Wednesday. The Lockwood Committee has been fastidious in working out what to do with our donated money, and we're going to start by grading to get ready for putting in a second daub pad and a second storage shed, and we're going to be removing the berm around the Gordon Mitchell Observatory to make it less of a injury hazard, and put in a new door that doesn't include climbing or descending. That's going to be awesome. So that's going to start on Wednesday, but we will be sure that there won't be anything untoward on Saturday. So you won't be in any further danger than normal should you go to family night. So that's what we have for announcements. But now we're going to do Good Heavens, and I'm actually really excited for this one, and this has been a long time coming. I would like to single out member Joe Phipps. Yep. Joe, whenever we see him these days, I mean, he's come all the way down from Wrightwood, usually on a motorcycle. He's cooler than the rest of us. He's got to figure it out where he doesn't need to bring anything anywhere because we just shower him with gear whenever he shows up to anything. He's got it worked out. But he's a longtime board member and he's a hands-on participant at so many club activities. I would like to shine some light on him this month for his work coordinating the swap meet potluck and the LIGO tour from yesterday. And both of those things were awesome. Let's see. We also know Joe for being the point person at for the blue club jackets and running the big telescopes at Griffith and Silver Lake Star parties, and for being a resource for members new and old on all things telescopery and astrophotography. Word. On a personal note, Joe is a mentor to me for learning the 26-inch and also for vouching for me to join the board of directors. The faith he put in me gave me the chunk of confidence I needed to commit to the bit. And I wish he were here so I could look him square in the eye and say thank you. I don't think he's on the Zoom either. So maybe on YouTube. Thank you very much, Joe Phipps. Yeah, oh, that's right. Okay, one other thing worth mentioning, which I was meant to put into the announcements, is we have so many green lasers still. We have so many, and the board of directors is tired of them. If you would like a green laser, come to Garvey. If you would like to give us some money for it, that's great. If not, take a green laser with you. Alan, we have yours here. Yeah, I know. I saw you. We got you, boo. The batteries on them they don't take a charge very well anymore because we've had them for so long. The replacement batteries are not expensive, and then they will be all that you wish they were in a short amount of time. Okay, and with that, let's give away some stuff, including green lasers if you so choose, but it doesn't have to be. It doesn't have to be. All right, so we're going to do 2 in here, and then you can do it. You're ready.
Okay, he's got to get the thing done. Okay.
Yeah. Did Roman, is the online raffle situation worked out?
Yes, it has.
Okay, awesome. Well, as is tradition, we'll do in-house first. 2. We're going to do 2 apiece.
All right. Is there anybody who did not get a ticket? Everybody has one? Here we go. The number is 8335 667. Oh. Who's got bingo? What, right up there. Come on down. We need to get your. Oh, duh. Okay. Yeah, oh, we know who you are. Okay, we're good. What did he win? $50 on the web store. Okay, that's pretty cool. And by the way, if you haven't been on a web store, check it out. We got a lot of new gear in there, including the 100th Centennial jackets, and they're really cool looking. They're very nice. Okay, here we go. Last one is 833 5678. Oh. Okay, there you go. And if you would just get the information to Keith, we're good. Okay, thank you.
Congrats to the winners. Actually, the web store is really cool. If you haven't been up there in a while, it did get an overhaul. There's all kinds of stuff. It's not just black and blue stuff anymore. There's all manners of everything to fit your mood. All right, Roman, have at it. Make some dreams come true out there.
Our first winner is Mark Schaefer. And our second winner is Elizabeth Wong.
Awesome.
I will send the information.
Hey, thank you.
You are welcome.
All right, fantastic. Yeah, so all that stuff, you all will be getting emails from Justin Hawkins, who runs the web store, and then you can fulfill your bounty. Yes, sir. Oh, is that for the raffle? I thought that was just a club donation. Oh, it was for the raffle. All right. Well, for the members, so either. All right, hang on a second. If it's for the raffle, you have an option then. We're gonna do all right. Let's pick another one for the instrument.
For the what?
I mean, yeah, they didn't know that they had a chance to win it. All right, here's what's going on. For those of you in house who won, you have the option of winning a 90 millimeter Maxutov. It has a Vixen mount on the bottom, and it has the visual back on it, and it looks like it'll take a Cinta finder. Who wants it? You didn't win.
What?
In lieu of a $50.
Are we organized or what?
No. We're freewheeling it. Okay. Yeah, that's awesome. All right, come and get it. All right, yes, sir. Your wishes are fulfilled. Thank you. What's your name? Thank you very much. We promise we won't turn into like the bathroom queue.
It's a new Centennial hat. Mount one of those hats.
It's used, but it works.
Thank you. Awesome. Optics were clean, unlike my humor. Okay, so all right, I kind of went over what's going on this week specifically, but I'll run down the whole month. The next general meeting here is going to be on August the 10th. The next Griffith Star Party, as I mentioned, is going to be this Saturday, 7/18. The next outreaches that I'm aware of is going to be Silver Lake on Thursday. That's going to be a big one. If you've always wondered what that hubbub is about, it will be that hubbub this Thursday. Look for the email to be coming through from Andy Sherwood soon. Family night this Saturday, 7/18. Hopefully the weather will hold up, unlike it did for Dark Sky Night. And speaking of Dark Sky Night, the next one of those will be next month on August 15th. The next Mount Wilson Star Party is going to be this Friday, 7/17. And if all that sounds too much fun for you, but you still want to be part of the club in a much less exciting way, you can sit in on the board meeting and see, what keeps us ticking on August 5th. It could be more boring. It could. It could. There is at least 2 laughs per. I guarantee it. And if you're wondering how decisions are made at our Dark Sky site, that is the Lockwood Committee that does that. And the next one of those meetings is going to be on August the 3rd. There's no qualifications other than just wanting to show up. for these meetings, and you can help steer our dark site into the next century of dark-sightedness. Okay, that's all what that is.
We have 3 green lasers here, just so you know.
Oh, can we give one to Megan?
Okay, you got it.
Yep, and then Alan has one too. So we have two. We have one green laser left that's not accounted for. If somebody wants a green laser, there it is, and Eric wants it. There's no more green lasers here. Yep, we're making it rain green lasers. Laura May would like to make an announcement, and so she will.
Hi again, everyone. Just wanted to let you know we received this awesome book from a friend of mine, Mark Johnston, who is one of the best solar photographers out there. It's full of actually really cool technical information. This is super nerdy stuff. So if you're interested in photographing sunspots, prominences, etc., this has got everything. This looks like the Bible. It'll live at Garvey, I guess. Yeah, so feel free to borrow it from Garvey and return it if you want to do some solar photography. So I think that's it. Do we have anything else?
That's it.
All right. Well, good night, everyone. We mentioned that you mentioned it, didn't you?
I didn't know.
Okay, yes. So our speaker next month, for anyone who is still watching or who plans on who thinks that our planetarium meeting is next month, it is not. It's going to be the September meeting this time. I know last year was August, but the planetarium meeting again is going to be in September. But next month we have our former president, who will be. What is your? Do you want to come talk about what your? Do you want to just give a sneak preview? All about Betelgeuse. Exciting. Will it blow up in our lifetime? Do you have the answer?
I do, but you have to wait till next month.
You have to come to the talk. You have to, connect. So even if you're at the eclipse in Spain, connect and watch the talk from everywhere in the world. We will be expecting you. And again, the planetarium meeting, that will be in September, and that will be at 7 p.m. But we will send out some announcements about this. Anything else we need? Are we okay? Go for it.
I'm sure you've seen the LAAS jackets. These here, the originals. How many here would be interested in purchasing these kind of jackets? Just curious. Hands, please. Raise your hand. We don't know one hand, please. Oh, so that's 2. How many? 3, 4, 5, 6, 7. Okay. All right. We need at least 12 to have it to do an
There's
order.
one
So,
online.
8 up there. Okay. All right. Thank you. All right. There you go. That's your answer right there.
And the one online. Well, all right. So,
Well, I think we're up to 3 online now.
all right. So that's over 12. So, go ahead. Ask Joe. You're on the board. You can do it.
Yeah, but you're the president.
All right. Board member. Ask Joe. Presidential is all get out. All right, everybody, go home. Thank you very much.
Jack, turn on your